Hi students, now we are going to discuss about an object rolling down an inclined plane. You can see here AB is an inclined surface on which a round object, maybe a circular plate, disc or sphere. Its shape is round and its radius is r and mass is m. So when it is kept on the inclined surface at the point A, its initial velocity, its initial velocity is 0. When I leave it, it will roll. It will roll down the inclined surface and reach the point B. So it travels a linear displacement AB is equal to S. So I have written here mass of the object is m, radius of the object is capital R, and its displacement is equal to AB equal to S. Now, first I am going to derive an expression for the acceleration of this object. Okay. So, what are all the various forces acting on the body? Let us see now. The point center, at the center, its weight mg is concentrated. So, I have drawn a straight line perpendicular to the horizontal surface, that is mg. mg is its weight. Weight always will be acting in the vertically downward direction. Okay, for this the normal reaction will be acting. You can see the normal reaction is acting at the same point, but it will be perpendicular to the surface on which the object is moving. Is it not? So N is acting at some angle, with respect to the weight. Okay, what is the angle of inclination here? The inclined surface is at B, inclined at an angle theta. Theta is the angle of inclination. So now you can see this is the weight mg. Weight mg is acting in the downward direction. I will split this mg into two perpendicular components. One along the direction of motion and the other one is perpendicular to the direction of motion. So that you can see that this angle with the vertical is again theta. So the component acting along the direction of motion will be mg into sine theta, and the other component perpendicular to the direction of motion will be mg cos theta. This is mg, this is theta. So this component will be mg into cos of this angle, mg cos theta. So the other component must be mg sine theta. Now this mg cos theta is acting along the same straight line but in opposite direction to that of the normal force. So N is equal to mg cos theta, they will cancel each other. Also there is no acceleration in the direction of the normal reaction. So the acceleration is along the direction of the other component mg sin theta. So if you imagine the free body diagram, for this forces means these two forces will cancel each other. Mg sin theta is acting along the x-axis. Acceleration also is acting along the x-axis, and the frictional force between the object and the inclined surface, that is the maximum value of the static friction. So that is F acting in the upward direction. So under the action of these forces, this rolling object will be accelerated. We want to get first the expression for the acceleration, and next subsequently we will go for the next derivation with what velocity it will touch the point B, the lowest point. Then after that how much time it will take to reach the point B. So now first let us derive an expression for the acceleration. So now the component mg sin theta is acting along the direction of motion, say x-axis. So I can write mg sin theta into I cap. And the frictional force is acting in the opposite direction. So this is minus F into I cap. This must be equal to mass of the object m into acceleration. Acceleration also is acting along the positive x direction. So this is a I cap. Now equating the components, I can cancel I cap on both sides. Therefore what I can write now, mg sin theta is r minus f is equal to ma. As it is, I am keeping. This is our first required equation. So mg sin theta minus f must be equal to m into a. We have studied the free body diagram as an application of Newton's laws of motion, isn't it? Net force on the left side and that is equal to mass into acceleration on the right side. Okay, now you can see here in this picture, this force, frictional force acting perpendicular to the radius of the object will produce a torque. That is what a torque is equal to r cross f. That is r into f into sine of the angle between r and f is 90. So sine 90 is 1. So the torque acting on the body tau is equal to r into f into sine 90 actually. So r into f. Now the other component mg cannot produce a torque about the center. About the center, if you want to produce a torque means the force should be perpendicular to the radius. So this force mg is acting through the center itself, and hence mg sin theta cannot produce a torque. So the only possible torque acting on the body must be due to the frictional force. So this torque is r into f. Now by definition we have studied torque also is equal to moment of inertia into angular acceleration, isn't it? So this is like second law, Newton's second law, F is equal to m into a, we have studied in linear motion. So in angular motion, torque tau is also equal to I into alpha. Now I am going to equate these two. So r into f is equal to I into alpha. Okay, now the mass of this object is m and the radius of the object is r. Suppose if this object is a circular disc, means what should be its moment of inertia? M r square by 2. Okay, suppose if it is a spherical object of the same radius r, means what should be its moment of inertia? It is 2 by 5 mr square, isn't it? But in general, if m is the mass and k is the radius of gyration, then moment of inertia is equal to what? Moment of inertia is equal to m k square in terms of radius of gyration, not in terms of the radius of the object. Okay, this is in terms of radius of gyration. For any object we can write m into k square. Also a acceleration, linear acceleration. Okay, so this is equal to radius times alpha, or alpha is equal to what? A by r. So I am going to substitute for moment of inertia I is equal to mk square and angular acceleration alpha is equal to linear acceleration by radius. So now this equation r into f, therefore r into f is equal to mk square into a by r, or I can write f is now equal to m into a into ma I have taken. So in the bracket I will write k square. By this r will come down as r square. So this is our equation number 2. Okay. So f is equal to ma into k square by r square. Understand? Now I am going to substitute this for f in equation 1. Okay. Therefore, okay, substituting 2. So 2 in equation 1. I will rewrite mg sin theta. Okay, mg sin theta minus f. Instead of f, what shall we substitute? Ma into k square by r square. So this is ma into k square by r square, and the right hand side is ma. So this is ma. So I will bring this negative term to the right side. It will become mg sin theta is equal to ma plus ma. This ma I have written here. This minus term comes as a plus ma. into k square by r square. So m can be cancelled on both sides. So g sin theta is equal to a common factor if I take means a into 1 plus k square by r square. Therefore, what is acceleration? A is now equal to g sin theta divided by 1 plus k square by r square. So this is the required equation number 3. Okay. So acceleration of this. Do you remember that we have already derived a similar equation? Suppose if a block of wood in place of this rolling object, when a block of wood is placed at this point, it does not roll. It will slide. Is it not? For sliding object, do you remember we have derived an expression A is equal to simply g sin theta only we have derived. Is it not? Suppose if the same object is falling freely, then what would have been its acceleration is A equal to g only. Same object sliding means g sin theta. Okay. So if this object is rolling means then its acceleration is g sin theta divided by 1 plus k square by r square, where k is the radius of gyration and r is the radius of the round object, maybe a sphere or ring or disc. Okay, have you understood? Now after this we are going to derive with what final velocity it will reach the point B. Understand? So for that now you see here in this inclined surface angle of inclination is theta. Okay, opposite side to theta is height h, and the hypotenuse AB is equal to what? The displacement s. So I get an expression for sin theta. So what is the sin theta? I will write here. Sin theta is equal to opposite side divided by s. So this implies s is equal to what? H divided by sin theta. So this equation is required. I will keep it as number 4. So the final velocity, okay, final velocity expression is v. Okay, v is the final velocity with which it is touching the final point B. So for that I am going to use the equation of kinematics. We have studied 3 equations, and the third equation is what? B square is equal to u square plus 2as. In this equation, what is the initial velocity? U equal to 0. So v square is now equal to 0 plus 2 into, in place of acceleration I am going to substitute equation 3. In place of displacement I am going to substitute equation 4. Simply substitution only. Next step will be the final derivation itself. Okay. So 2 into A is g sin theta. Okay. 2 into g sin theta divided by 1 plus k square by r square into s is what? Into h by sin theta. Okay. So sin theta can be cancelled, and the remaining will be v square is equal to 2gh divided by 1 plus k square by r square. This implies v is equal to square root of 2gh divided by 1 plus k square by r square. So this is another derivation, and this is equation 6 or 5. Okay, this is equation 5. So we got first expression for v square and we took the square root. Okay. Now you have to remember, suppose for a sliding object, I am recalling that expression. For an object which is sliding, do you remember that we have derived this expression as what? V equal to square root of 2g sin theta into s. Understand? In place of that, it is coming now, sin theta gets cancelled. So square root of 2gh by root of 1 plus k square by r square. Now next is how much time it will take to reach the lowest point, that is time t. Okay, time taken. So that is the final derivation. It is again very simple, students. We are going to use the equation of kinematics, V equal to U plus AT. Okay, so the first equation, V equal to U plus A into T. So V equal to 0 plus AT implies T is equal to B by A. Simple. For V, we are going to substitute this equation, and for A, this equation, we have to divide and get the expression. Therefore, now V is equal to, that is a T is equal to B by A. Is it not? Instead of V, I will write this first. So this is a square root of 2GH divided by 1 plus K square by R square. I have to divide by A. Otherwise, I can multiply by the reciprocal of A also. So I will multiply the reciprocal of A, I will write. So here 1 plus K square by R square whole divided by G sin theta. Okay, G sin theta. Now this term is inside square root. This does not have square root. So here also, if I want to bring this inside the square root, means then I can take a whole square, isn't it? So this is also equal to square root of 2GH divided by 1 plus K square by R square into, here 1 plus K square by R square is there, but when it is brought inside the square root, it will become whole square divided by G square sin square theta. So this is G square sin square theta. Okay, therefore final expression for the time taken T. So what will be cancelled here is this power, this square power will get cancelled, so that this entire term 1 plus K square by R square shall be cancelled. Then here G square get cancelled, one G term get cancelled. So this T equal to, final equation is what? 2H into, okay, 2H into 1 plus K square by R square divided by G sin square theta. So this is a G sin square theta, and this will be the final equation number 6. So all these are related one with the other. So if you understand what are all the various forces acting on the object and start with the acceleration, means correctly you can substitute and end up with the right equation. Okay children, I hope you must have understood well. Fine.